Okay, welcome to week 7 of your summer math. And week 7 and week 8 kind of go together where we're going to move into a new topic over parallel lines. And it seems like that's parallel lines is not like a complicated enough idea to take a couple of weeks, but you will not believe all the relationships that actually do exist there. So let's start off with just what do you remember about parallel lines? And if you'll take a minute and think, and you can fill in anything you want right here with stuff that you might remember from the past. A lot of people can just imagine in their head what parallel lines are. I see a lot of people usually take their hands and draw something like this. They're like, oh, they're two lines like this. They could go sideways as well if you want to do that. But most people remember that it's two lines that don't touch. And you could even put, go side by side and don't intersect. In algebra, you actually spent a lot of time with parallel lines as well, and you approached it from a standpoint of slope. So from algebra, what you may or may not remember is that two parallel lines have the same slope. And you would probably have to do stuff where you would have to count like the rise over the run, the rise over the run, and then you would do that here. Rise over run, and whenever you did x over y and all that, you would notice it was the same. So that's both true from algebra and maybe even from middle school, but now we take it a step further, because we're in geometry. And so what are all the relationships and things that you will study? Well, the first thing is I want to talk about notation, okay? So when you are trying to say that two lines are parallel, okay, there's two things you're going to notice, okay? If I draw two lines and they look parallel, okay, don't assume they're parallel unless you see a little bitty arrow on them. Whenever you see these arrows on two lines, that would be, it's like an arrowhead, like a triangle almost. Whenever you see the two triangle arrowheads, whatever you want to call them, that is a clear sign that these are parallel. If you don't see these, like let's pretend this is line L and this is line M, okay? So if they were labeled with an L and an M, another thing you might see is they might just tell you, oh hey, by the way, line L is parallel to line M. And the two long, tall marks right next to each other, that's the symbol for parallel. I think a lot of people kind of know that from back in the day as well, but if you haven't seen it, there it is. So you'll either see this or you'll see that, okay? Now what's going to happen here is that we are going to be studying all the relationships of when two lines are parallel, what are relationships between the lines. And in order to be able to do that, you have to introduce a third line that's actually called a transversal. Now, it's not a third parallel line, it's actually a third line that intersects the parallel lines, okay? Intersects a pair of parallel lines. So when I draw this, I'm going to draw this same picture here, okay? And remember, parallel lines can go anyway. I like to draw them sideways because then it's a little bit easier to see. Okay, so these are parallel, and I'm not going to fill in the little triangle. We'll just draw an arrowhead. These are parallel, and the transversal might look something like this. Whee! Okay, now there is no rule about which angle it has to cross at. Like it can come in like this, it could have gone in from the side, it could have gone straight up and down. It really doesn't matter. But this blue line would be the transversal. There's no special notation for a transversal. Somebody would just have to tell you it's a transversal, okay? And what happens is now we get to study how all these different angles relate to each other, because I don't know if you can see it or not, but there is a ton, or there are a ton of little angles that just came about the minute we drew that blue line. There's an angle here, 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 here. Then there's an angle here, 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 here. And there's 8 of them there. So all 8 of these angles do have special relationships to each other. And week 7 of summer math is going to be the vocab. It's going to be how everybody relates to everybody else. So what you're going to see me do is draw the same dang picture over and over and over, okay, where here we have our 2 parallel lines, and I'm going to draw our transversal, okay, and we're going to talk about on this picture what each thing is, right? So first we're going to talk about something called a vertical angle, okay? Now, a vertical angle doesn't mean that it's going straight up and down. It really doesn't. A vertical angle has to do with 2 angles that back up to each other, that kind of go back to back. And it's not back to back like sideways. It's actually back to back like, well, like you'll see right here. Like this one that I'm going to call angle 1, and this one I'm going to call angle 2. These 2 are congruent, okay, and they back up where they have the same vertex right here, okay, and the way I used to tell my class to memorize it is V for vertical, so it would be like look for the V and then the other V that backs up to it, okay, so it's almost like an X, I guess, but if you look at that as an individual V and an individual V, that might help you remember vertical angles, but the idea is that they are congruent, okay, so angle 1, angle 2, and now we need a symbol for congruent, okay, so most people do that for a symbol for congruent. They do 1 wavy line and then 1 solid line for congruent. And I've seen several things. I've seen 2 wavy lines. So, you know, your teacher will tell you what they want you to see or to use. Okay, so those are congruent. So that means that if I come down here, there's other ones that are congruent, right? Like if I put a 3 and a 4, those would be congruent. And I could even do others, like I could do, let me do some in black. I could do the other diagonal. So what do you want to call this? Like maybe this is 5, 6. So you could do 5 is congruent to 6, 7 is congruent to 8. And I'm not going to write that out, but you get the idea. You can go either way across the diagonal, and those would be congruent, okay? Now, what is a corresponding angle? This one is very cool, and if you see geometry well, this will make the most sense to you. A lot of people notice the symmetry in this picture. In other words, they notice that if I were to cut my picture in half right here, just imagine I'm cutting the picture on the dotted line. If I were to cut this piece of paper in half and then I picked up this and laid it on top of this, okay, that things would match up. So in other words, like if I'll call this one angle 1 now, if I were to pick this up and lay it on top of this one, well, which one would that match up to? Well, it's in the upper right, so it would match up here to that upper right. That is a corresponding angle, okay? So they correspond to one another in terms of, you know, I don't know how you want to write it. If you want to do like upper right equals upper right, upper left equals upper left, or if you just want to think of cutting the picture, if you're visual, that's kind of what's happening. So angle 1 would be congruent to angle 2. And then if I put a 3 here, angle 3 would be congruent to angle 4. Now where would that go? Well, if that's in the upper left of this little grid, then it would be that one, okay? And the same thing would go for these 2. So we could do, if we want to do a 5 or something right here, 5 and 6, it would be these 2, lower left, and then 7, 8 would also be congruent lower right. So feel free to write all 4 of those out if you like, but this is just kind of an idea of how this works, okay? So those are corresponding. Okay, alternate interior angles. Now, if you're good with the English language, then a lot of these are going to make sense with you if you understand like those 2 words on their own. Then we're just going to put them together and ask like, what does that even mean? Okay, well, first of all, interior. Interior means the inside. So basically the inside of the red line. So when you see that, you can think inside red lines. or inside the parallel lines. Okay, so we have to be within this region right here, and I'll just kind of do a little dotted, there we go, we're on the inside now. Okay, and alternate. Okay, well, we say it as alternate, but you know that is the word alternate, right? And when you alternate, you alternate. A lot of people think about crisscrossing, you know, you alternate between two things. That's exactly what this is. It's kind of a crisscross idea. So if I were to put an angle right here and say, well, that's angle 1, okay, well, if I stay on the inside but I alternate and go to the other side of the blue line, that would be my angle 2, and those guys are congruent. Okay, so angle 1 is congruent to angle 2 in this picture. That would be alternate interior. These two would also be. So if I did a 3 and a 4, then they would also be considered alternate, alternate interior. What is that for? Okay. All right, cool. So that's it. There's only a couple of combinations for those. You can't choose these angles because now you're on the outside of the picture. You're no longer on the inside, so it doesn't classify or qualify as an alternate interior. A memory trick for this one, if you don't like the whole think about the English, I used to tell my students to look for the Z in the picture, and it's kind of a distorted Z, but there we go. If you look for the Z, then it's the inside of the Z, and those things equal each other. All right, cool. So look at all this junk that's equivalent to each other by all these different vocab, by relationships. So are they always going to be angles that are equal to each other? The answer is no. You have one other option. These are all the different types that equal, and we're about to talk about the types that are not congruent, but they are supplementary. Now, what does supplementary mean? Well, from last week, they have a sum of 180 degrees. Okay, so let's draw the same picture again. We're getting good at this picture, aren't we? Okay, let's see. Okay, so if we draw this picture, and I haven't been drawing my parallel lines, so shame on me. If you want to go back and add them on the other pictures, that would be a little bit better, actually. Okay, so here we have our picture, and we're going to break this down the same thing, same side interior. Well, if you're interior, once again, you are on the inside, right? So we're on the inside, and you're on the same side of the transversal, okay? So that same side means same side of transversal, or of the blue line, and you're on the inside, and those are supplementary. So 1 and 2, I would label them like that. And now I'm not going to write 1 is equal to 2. I'm going to write angle 1 plus angle 2 is equal to 180, because they have a sum of 180 because they are supplementary. That's how that works. And same thing if you want to do the other side. These are on the inside. They're on the same side of the transversal, so they must also be equal to 180. Okay? And then over here, same side exterior are supplementary. So now we're going to do same side exterior. So you probably have a good idea of what this is going to be. And if not, push pause and think about it a little bit based on what we just did. But it's really not bad at all. It's kind of the same idea, right? Now, though, we're not on the inside anymore. Exterior means outside. So we are outside of the parallel lines. So I'm kind of circling these areas here, okay? So we're outside of these red parallel lines, and we need to stay on the same side. So if we stay on the same side, then like if I put a 1 here, I stay on the same side and I put a 2 down there, those guys are supplementary, okay? Angle 1 plus angle 2 equals 180, just like we did over here. Okay, and then the same thing over here. You could do 3 and 4, but you need to stay on the outside. And you could have the same little rule. Angle 3 plus angle 4 equals 180. Okay, cool. Now, I didn't write this as one of your rules, but if you want to add this, some of you might be thinking, okay, well, what about alternate exterior? What about angle 1 and angle 4? Well, what do you think their relationship would be? Okay, well, it turns out they are congruent. And so if you want to add that, you can come back up here. It doesn't happen as often, so that's why I didn't really put it. But if you want to add another box of same side, nope, not same side, silly me. It's almost like this one, right? Alternate exterior, then it would also be congruent. And you could draw yourself a picture for that if you want. 1, 2. We'll make these the parallel guys, even though they look a little distorted. And so alternate exterior, that would be like outside of this one is up here. And then outside of this one, it would have to go across the blue line, so it would be like that. Angle 1 is congruent to angle 2, something like that. Okay, cool. And like I said, this one doesn't show up as often, but feel free to add that to your paper, just in case you run into it. All right, cool. So that's pretty much, well, that's not pretty much, that is every relationship that these angles have. So what we're going to do is practice the whole putting it all together to where I kind of draw you a picture, and we're going to talk about which ones are congruent, which ones are supplementary, and we're going to have to justify why, okay? And so let me call this like 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have labeled every single angle in my picture. Now there's no parallel markings, so add those on your picture because we are gonna suppose and assume that those are parallel, okay? And now we're going to talk about all the relationships. So if we wanted to talk about, like, let's say, what is congruent, okay? Well, when you look at this picture, let's just name a couple of things that look congruent. Well, I think that I always, you know, kind of like to stay within one area first. So I look at the crisscrosses and I'm like, oh, okay. So that would be like angle 1 is congruent to angle 4. That's what I would write, okay? And then the reason for that is I would do vertical angles. Now, are there any other ones that you could have listed as vertical angles? Because those are the ones where the V's back up to each other. You might have thought of 2 and 3, because they definitely form the X, or the two V's that back up to each other. Or you might have gone down here and said 5 and 8 and 6 and 7. So we could list every single one of those out for vertical angles, okay? But I'm not going to. I just chose one. So now let's look for some other set of what was listed above. So I think the next one listed was corresponding angles. So if I start with angle 2, what would it be congruent to? All right, well, angle 2, and if you need to, you know, turn your head to the side a little bit and imagine cutting that paper in half, right between the parallel lines. This is in the upper right, so when you lay it on top of this set, it would match up with number 6. And that is called corresponding. And then the last one that we listed in a box was, what was it? Alternate interior. So now I need to stay on the inside of my picture, so in between the parallel lines. So I'm looking at all of these right here, and I need to look for which ones alternate. So you go across the line, you alternate across the transversal. So angle 3 is congruent to angle 6. Now you could have done 4 and 5, that would be the same thing. So you have like a lot of choices, and I have seen some teachers that want you to list out every single possibility of everything, so you would have like this huge long paper listing them all. I'm just trying to find one example of each of the types that we covered, okay? So what's left is supplementary. Okay, so supplementary would be, we only have a couple of examples of those. One of them was same side interior. So that would mean, so let me write down same side interior, and then we'll look for an example of that. So we need to stay on the inside because of the word interior, and we need to stay on the same side of the inside. So maybe 4 and 6. And we're not going to put that they're equal. We're going to put that they add up to 180. Okay, what else would add up to 180? Well, 3 and 5 also add up to 180. And then the other one that we put was same side exterior. Okay, so same side exterior would be like we go to the outside, so we either choose 1 and 2 or 7 and 8. So somehow those are all on the outside of the parallel lines. We stay on the same side of the picture. So maybe angle 1 plus angle 7, or you could have done angle 2 plus angle 8. And the reason I notice I stayed on the same side of the blue line, okay? Because if I jump across and I call it like angle 1 and angle 8, then angle 1 and angle 8 end up being congruent by that other one that we wrote down that we added. What was that called? Alternate exterior angles. All right, cool. So this is going to be a lot of your geometry, and it's one of those deals where you're going to do it a few days, and then everything else you do throughout the year, like you're going to have to remember this junk, and they're going to be like, why is that true? And you'll have to know this vocab and these relationships and sort of how it all works. The only other thing I wanted to do was more of a fun thing, and where I'm not really, well, I say fun thing, it may not be too fun. What if I put like, I don't know. What if I put like an X right here and a Y right here, and I asked you what their relationship was, okay? Are they congruent or are they supplementary? And you have to tell me why you think what you think, okay? So how would we do that? Well, when this happens, you may just look at the angles and notice that they don't look to be the same size. So you're thinking, well, they don't look congruent, so maybe they're supplementary, but how can you prove it? Well, what I would do is I would look for what we could prove. In other words, I would say, well, if this one is x degrees, then I know that this is also x degrees because of vertical angles, right? So from here to here, that's a vertical angle problem. And I know those are congruent. That's why I labeled them the same. Now look what you have right here. We're on the inside of the parallel lines, okay? And we're on the same side of the transversal. So if we're on the same side of the transversal and we're inside the picture, we are doing same side interior. And by the same side interior, x plus y equals 180. And that would be my justification. I would show the vertical angle thing and show that they're the same side interior. And so that's how you work your way around the picture. So no matter how these pictures are turned, look for those parallel lines first. Then look for the third line, call that your T or your transversal. That way you can really look for what's on the inside, what's on the outside, and how to do this stuff below. So go ahead and try the practice problems, and hopefully that goes well for you. And of course I'll cover whatever we need to cover in tutorials and the solution video.